Alright guys, so this is a very interesting topic, which is VFD biasing. VFD biasing is most widely used when you want to shift your curves, which is quite confusing for many of the people. So what do I mean by that? There's a VF curve, voltage to frequency curve. Now we know that control voltage range is 0 to 10 volt. Frequency range by default is 0 to 50 Hertz. Alright, so this is the nominal curve which we have in the drive. At 0 volt we have 0 Hertz frequency. At 10 volts we have 50 Hertz frequency. Alright, so proportionally at 5 volt we have 25 Hertz. This curve is by default, and there are certain parameters which are related with that, which defines this curve. These are by default. So these parameters are maximum output frequency, which is 50 Hertz. That depends. If you have a 60 Hertz, you should put 60 here. So your range becomes 0 to 10 volt to 0 to 60 Hertz. It's depending upon your electricity supply parameters. Now bias adjustment is 0% by default, so there is no biasing. We'll be doing these adjustments. Bias polarity is 0. Potentiometer gain is, this is not 0, this is 100% by default. Alright, and reverse, disable and negative bias, I'll be telling you what is that, why we disable reverse. Okay, so this is by default. If you want to see these parameters, these are, let's just verify once that if you are on the same track or not. So 48, that's 0, 49, it's 0, 50, it's 100, 51, it's 0. Okay, so we are on this parameter, and to see the response I'll be using analog cards to give the frequency command to the drive. Alright, so I'll make this logic very quickly. So I'm using D2A card, which is my second and the second port. Setup, output mode settings, right resistor, 1000, add to rest, and this is my channel 2 output, right resistor, M1000, set value, I'll take a data resistor here, that should be D0, add to rest, okay, and okay again. So if I go to online, now D0 defines my voltage, and just to recall, if you are not familiar, my resolution of this card is, if I give 0 bit, I will get 0 volts on the output, which is equivalent to 0 Hertz. If I give 4000 bits, that will give me 10 volts, 10 VDC, and this will give me 50 Hertz. This is my resolution. So let me show you how does it work. Yes, now D0 is 0, so there is no voltage. Frequency, if you see in the graph, is 0. If I give K 1000, that will move the frequency to 12.5 Hertz. That's there. And if I give 4000, it will be 50 Hertz. So that's the curve by default in my drive. Alright, so we are going to see how we can shift this curve. Alright, suppose we want 10 Hertz at 0 volts, not the 0 Hertz. We want to shift this curve like that, not like that, but like that. And at 0 volt we should give some frequency. It should not start from 0. So we'll be seeing that in step-by-step approach how to change the parameter. There are of course certain formulas related to that, which we are going to enter in our drive, and we're going to enter the parameters in the drive related to that. So these will be used to change the biasing. Alright, so in couple of videos we'll see how to do the biasing. So as of now I'm going to control and demonstrate this biasing by using analog cards, but this can be done using a potentiometer as well. It doesn't matter which voltage source you are using. It just matters that your voltage is being clipped or being offset or having a more gain. That's all about biasing. Alright, so I'll see you in the next videos.